theta is equal to 0. So I make a trig substitution here, 2 times the integral from 0 to pi over 2, square root of cosine squared theta, then cosine theta d theta. So this gives me 2 times the integral from 0 to pi over 2 of cosine squared theta d theta. So by the usual trigonometry, this is the integral from 0 to pi over 2, 1 minus the cosine, plus rather, the cosine of 2 theta d theta. What happened to the 2? The trigonometry ate it, right? And then we integrate, and we get theta minus, plus 1/2 the sine of 2 theta, evaluated from 0 to pi over 2. And of course, that gives us, not surprisingly, pi over 2, right? Which makes sense because this is the area of half a circle of radius 1, right? The area of the whole circle is pi. I did it for radius r in my notes. That was more exciting. And actually, just for a quarter circle. Oh well, too late. Any questions?
What happened to the 2 at the beginning?
Which 2 are we talking about? This the invention. This is because cosine squared theta is 1/2. Yeah.
The reason that you can take the square root of the cosine squared as just cosine is because we're going over from 0 to pi over 2, right? Where it's positive.
Yes. So he's asking about the disappearance of the square root in terms of for the cosine. Indeed, it is the context that allows me to not worry about plus or minus cosine there. But of course, it's sort of trig substitution, right? So, yeah. See if I can find another good example for us. So suppose we have the region well, this is just an example. So integrate from 0 to, actually, I'll do this one a little bit backwards. I'm going to ask the question, what is the region over, let me just write it and then I'll pose the question. So here's the integral. So my first question is, this is the integral over what region of what function? So my question number 1 is, what is f of x comma y? And what's r? And then we'll calculate it, okay. So I'll do the easy part. F of x comma y is 16x, right? Okay, yay. Okay, that's the integrand. What's the region? I'll do the easy part. 0 less than or equal to x, less than or equal to 3/2. Now, sometimes I might ask you to picture the region, you know. We'll do that next. And then y is what?
Is it just 0 equal y being 9 minus 4 squared?
Right. So if we were to picture this, what does this region actually look like?
L facing ground. Oh, I think so, because there's no square.
Let's see, when you plug in x equal to 3/2, what do you get?
0.
I'm asking this ahead of time so that I don't get some kind of jibber jabber about my picture not being right, as seems to be customary in these parts. Let's see here. So there's a picture R. Now let me add one thing to our repertoire. So we got a way of calculating the integral. Even when it's, you know, curved and stuff, we just use this type 1 or type 2 idea. But we can also define, we got volumes, right? We got areas. We got integrals of densities giving us amount of mass or amount of charge or something like that, or chocolate, calories. But we can also define, so my question, follow-up question is, what's the average of f over r? So let me just give you, what do you think the definition, do you guys remember what the definition of the average was of a function over like a line integral? Or like, you know, if f average before was like 1 over b minus a, right? Integral from a to b. F of x dx, that's the average of f over some, like, you know, closed interval if we have a one-dimensional problem. Remember that?
So do you just do that twice?
But it's not a rectangle.
Just integrate where replace f with g where g equals 1. And then divide by that.
Yeah, I'll put you guys out of your misery. F average is 1 over the area of r. You might have said this, but I just didn't understand it. Integral of f so the average is defined to be that. You just weight by the area. Here you weight by the length. So to calculate the average, we're actually asking for 2 integrations to be done. So we can either do the, let's start with the integral that was posed to start with. So let's point number 1, the integral from 0 to 3/2, the integral from 0 to 9 minus 4x squared, 16x dy dx. What do we got? So we're integrating y first, right? So that gives me 16xy evaluated from y equals to 0 all the way up to y equals to 9 minus 4x squared. So rules of thumb here, guys, is that you know, once you're done with an integration, you shouldn't have any of that letter left over. After I'm successfully completed the integration over y, I shouldn't have y's left over. After I'm done with the last integration, I shouldn't have x's or y's. I should have a number. Right? These integrals represent areas or volumes or something. It's a specific numerical thing, unless there's like parameters running around. So, just a you know, general comment there. Let's see here. So what does this give us? This gives us the integral 0 to 3/2 16x times 9 minus 4x squared dx. I'll multiply it out. 0 to 3/2. What is 16 times 9? 144? 144x minus 64x cubed dx. So that gives us 144x squared over 2 minus 64x to the 4th over 4. Of course, we could simplify those, right? Evaluated from 0 to 3/2. And that is quite clearly 81. I mean, it actually is not that bad to work out. This is 72 times 9 over 4 minus 16 times 81 over 16. Huh. Weird.
It's 18 times.
What?
What? Wait. No, that makes sense. Oh, yeah, you're right.
It does?
It's 18 times 9. Wait.
It looks like minus 81 there to me.
Times 9 minus 81, right? So, I mean, that's 87 times 2 minus 81. Oh, no, yeah. Makes sense.
Oh, is this 2 times 81? Just messing with me.
I think. Yes.
Okay, so this is 2 times 9 times 9 minus 9 times 9. Yeah, okay, whatever. Anyway, 81, yes. All right. Now, that doesn't tell us the average. That just tells us the value of the integral. Now, to calculate the average, I still have to do what? So now we need to find the area, right?
Actually, instead of integral from 0 to 3 halves, that, it would just be 0 to 3 halves of 9 minus 4 squared.
I'm doing it in my calculus 3 way. But, of course, Sam was just telling me I just need to do this integral, which is fair. I mean, we've known that since calculus 1, right? So it's just giving us a new way to understand things we already knew from before. One way to look at this. That's 9x minus 4/3 x cubed, evaluated from 0 to 3 halves. So that's 9 times 3 over 2 minus 4/3 of 27 over 8. 27 over 2 minus 9 over 2, also known as 18 over 2, aka 9, is the area.
Yeah, very well. So it's just 9.
It's all right. So yeah, it's all 9. 9, 9, 9, 9, 9. I have many more examples in the notes, and I would encourage you to read those. We'll look at some more next time we meet. So like tomorrow I'll go over how to do volume integrals, right? There you have to worry about bounding both x and y in terms of z or something like that. I mean, it's a little bit more complicated, but really more the same thing. But, and then Thursday, finally, the test you've all been waiting for. See, I was sitting around last night and I was like, I just don't feel like writing a test today. It's the strangest feeling. Like, and then I read, Michael, your email was not the first one. Matthew? Yours was the first, but I read Michael's first because his came later. Because I always read from the top down because it's just how I am. And then it just like resonated with me because like yesterday I went to teach my 422 class and I had like written notes and I scanned and I was going to load them up on the computer with the email and it just wouldn't work and I just got so angry. So very angry. So I understand. Like I completely sympathize.